One day, as you were walking along the beach, you decided to throw a rock into the ocean with superhuman strength. Your super intelligent brain tells you that the rock left your hand with the speed of 150 meters per second at a 40 degrees angle. However, your super intelligent brain decided to stop working and you weren't able to find out how far the rock went. You were able to estimate the height of when the ball left your hand to be around 1.5 meters. How far did the rock go? Projectile motion usually involves angles, which is the thing over here, which is why it's important for us to understand the x and y components of a vector. So we have the y-axis and the x-axis, and both of these have similar values but are different from the actual vector. For x, you can define this by using v for vector and cos theta for the angle found over here. And the same can be done for y, except you switch out cos with sine. And doing these, you can find the y component of a vector and the x component of a vector. Okay, now, the second part that is important to solving a projectile motion problem would be knowing the formulas. Now, the formulas can be split into two parts, which is the formula for x-axis and the formulas for y-axis. The formula for x-axis can include some simple things like speed is equals to distance over time, which then can be used to find any of these three if the other two are given. Other than that, we also have Vix, which is the initial velocity on the x component, is equals to x over time. And this can be used to find the total distance, which is using the velocity on the x-axis multiplying the time given, and it will give us the total distance, which is x. Okay, now after we have the formulas for the x-axis, we also have the formulas for the y-axis. The most basic and important one, as well as the one we're covering in this video, will be y equals to ut plus 1 over 2 agt squared. And now in this formula, the u represents the initial velocity, while t here represents time, ag here represents the acceleration due to gravity, which is in most cases we can use 10, but if we want specific answers we can use 9.8 meters per second squared. Now, before we do anything else, it's important that we list down the numbers and values that have been given to us in the problem. The first being the degree, or the angle at which the rock has been thrown, which is 40 degrees. The speed is also given, which is 150 meters per second. And with this, we can already find both our components for y-axis and the x-axis, which will equals to 150 sine 40 and 150 cos 40. Now that we have the components for both the x and y-axis, we can then move on to trying to find the distance. A formula that we have, which is Vix multiplied time, will give us the distance. And since we know that we can get distance from this, and we already have our initial velocity on the x-axis, which is 150 cos 40, we then try and find the time. Another formula that we had is the y equals to ut plus 1 over 2 agt squared. And this is the formula for the y-axis, meaning that we will use our speed from here. Now that we know the formula we can use to try and solve the whole equation, we can start substituting in the values that we had from before. Y, in this case, is the 1.5 meters above the ground, which means it should look like this. But since we're trying to get the value from here, that means this will become a negative value. So the whole equation will look like this: negative 1.5 from the height it was above from the ground. U is 150 sine 40. T is an unknown, plus 1 over 2. A is negative 10 since it's acceleration due to gravity coming down. And lastly is t squared, which is also unknown. Okay, now we can try and simplify some of the values we have. For example, 150 sine 40, after putting in the calculator, you would get 96.4. And with this, we can rearrange to get an equation that resembles the quadratic formula, which is negative 1.5 minus 96t plus 5t squared. Now that we have this equation, we can then put it into our quadratic formula, which is minus b plus minus square root of b squared minus 4ac divided by 2a. And from the equation to our left, we can then see that negative b is 96, which is, because negative cancels each other, square root plus minus square root of b squared, which in this case would be 9,296 minus 4 multiply negative 1.5 multiply 5 square root of the whole equation over 2a, which a in this case is our 5, so it would be 10. We can then finish solving this quadratic formula by substituting in and solving everything else, which would be 96 plus minus square root, and after adding in all the values, we will have 9,326 over 10. And then furthermore, once we solve this, we can get 96 plus minus, after solving a square root, we will get 96.6 over 10. Since there's a plus minus sign, it's telling us that we can either add or subtract the values up there, up below, above the 10. So let's do both ways. We have 1, which is, if we add, we will get 192.5 over 10, or if we subtract, we will get negative 0.5 over 10. Now these will both give different values, the first one being 19.25 seconds, and the second being negative 0.05. However, time cannot be negative, so we will not use this part, and we will only use this answer from our equation, which means we have the time. Now that we have the time for our equation, we can substitute this back into our equation up here, which is Vix times time equals to distance. Vix, the initial velocity for the x-axis, is 150 cos 40 multiply time, which is 19.25, will result us with the distance of 2,211.95 meters in total.